Okay, so welcome to lecture 3 in this series. In this little session we're going to work through how to import data into R. So just to get things going, again what I've done is I've set up my own folder here actually. I've set up my own little folder structure. This is called R podcast module temp, just where I'm going to work whilst I muck around with these files. And into that I've copied the contents of the lecture 3 folder from the GitHub repository. So you should have probably already downloaded that. I took the entire contents just so that I can build the file properly and fully. I've renamed the file from L3 to just L3 importing data.rmd just so I can work on it here. And what I'm going to do is, so that this RMD file, when we knit it, remember, it gets rendered into this HTML. So that's this file here. So we're going to work our way through this HTML file. You can follow that. But for the purposes of this, I'm going to work through the markdown file over here instead, the raw markdown file. And I'm going to sort of copy the code across and evaluate the code as I go. So what do we have? So first of all, we're going to just remove, we're going to use rm, the remove function, to remove everything from the current environment. As I say here, it's not a complete remove, so if you actually want, and you can see I've been working up here in the console already, so I've already been working through it. So I'm going to delete all of that stuff. So I'm going to make sure we start with a brand new version of our brand new instance of R. So to do that, we can either press this shortcut command, Control Command Shift F10, or we can go up here to Session and hit Restart R. So I'll just go for that now. Just wait there whilst R restarts. That's it, restarted, and I'm going to clear that window with Control L. So we've got nothing. So now there's nothing going on there. We can double check that by just double checking the environment. So the global environment is empty down here. Alright, so that's us all set up and ready to go. So just to be sure you're working in the right working directory, if you've done what I've done, I've set up a project, I've set up a new RStudio project in this folder for lecture 3. So when I clicked on that, it set my working directory to this folder already, so it'll be able to see all these files. Because crucially, we need the computer, we need R to be able to see where finger length is easily. We don't want to go. We don't always want to go typing out longhand file addresses and directory strings. So for this to work, ideally you want it to be in your working directory. So you can confirm that with this function dir for directory. Just evaluate that. And that says the contents of the current working directory is finger data, R data, the fingerlengths.csv, and all these files that are down here that we're going to work with. And you can see that the working directory we're currently in at the moment is listed here. So you can see we got that. We can double check that again with the get working directory command if we want. So that's where I'm working. It's where I expect my files to be. It's where I want to be. It's where I want to be working. So everything's good to proceed. So when it comes to working with data, normally, usually we input our data into Excel. We still use Excel a lot. I would still recommend it, or at least any other sort of spreadsheet software. Google Docs is very similar. The Open or LibreOffice versions of the spreadsheet builders are exactly the same. But I think Excel is great. I have no major problems with Microsoft products, and I have no major problems with Excel at all. So the data we're going to be working with are here. It's this finger lengths .csv data. So basically all I've done is I've gone and taken a ruler and measured the length of my thumb, my index, and all my fingers on the left hand, and I've done exactly the same for the right hand. So I've done that and I've put it into this Excel file, and the Excel file looks like this. So I could probably spend an entire lecture talking about how to structure data and how you should best set up your data sets, but by and large it's reasonably simple. By and large, the best way to do it is to set it up so that you've got, in the top row, you've got the names of your columns, so the names of each of the collections of data, the vectors of data underneath it are set up there. So here I've called the first one digit, so that's going to identify which digit it is. So that's the first digit, thumb, second digit, third, fourth, and fifth digit, little finger, on which hand? On the left hand. So each row is a unique observation, and that's the other rule. So each row there is a unique observation. That's a finger, it's got the length of the finger, it's got which hand is it on, and it's got which digit does it refer to, and similarly the second one is there like that. So that's definitely the best way to do it, as you'll see and that's how you should do all your data. So each row is a unique observation, and all the information associated with that data point there, really, that's the thing that we're interested in, that finger length there. Everything else that's associated with it is in another column. It's in its own column to the side. The other way you might have seen that data collected, we'll see it in the example file. I just have to knit that again. See it in the associated HTML file. Here you see we could have done it this way. So we could have set it up so that we've got the left hand, right hand beside each other, and that's not an appalling way to set up your data. That's called the wide format data, as opposed to long format data, which is the other one here like this. You'll see this format here is actually more efficient in terms of it uses less information to contain the same amount of data, whereas this, and we end up having to have two extra columns essentially for which digit is it and which hand is it, etc. Because we've got a hand left, and then to demarcate which digit is it, we've got to have 1, 2, 3, so they get paired up, so we know that the first digit here pairs with this one here, whereas up here we could just see, well, the first one, this is paired with this one. So you'll see it increases the amount of data that's required to store the same information, but this long format here is far easier to work with in a statistical sense, and certainly in this for R, and certainly when if you were to move on away from base R and move into the world of the tidyverse world of using things like ggplot and dplyr, etc., and tidyr, which we will hopefully cover in subsequent lectures. But this, even though this is the better way to do it by far, this approach down here, the long format, is the one that's going to let you do graphing much easier. It's going to let you do certainly your statistical modeling far easier. So I recommend this always. Okay, so that's our data. So we've got our data formatted in Excel. The other thing that you'll notice is we want to save it not as an XLS file or an Excel file, but you actually want to save it out as a CSV file. So you go up here to Save As. We would choose the name of the file, finger lengths. We would choose the name, file format, comma, separated value, and we save that. It's going to say, do I want to replace it? Yes, I do. And that's our data saved. So if you had it in an Excel format file, you would save it out before you're going to import it into R. You would save it out into CSV, at least CSV or one of the other delimited options. I'll talk about that in a few minutes. So we can close down Excel there now. So that's typically what we would do. We'd input our data into a field notebook or a lab notebook or something. Then we'd input it manually into an Excel file, check it all, get it manipulated into that long format structure for us, and then we save it out as typically a CSV file. And now we can start bringing it into R and working with it. So when we look at that CSV file, so Excel doesn't show us it, but CSV stands for comma separated. So if I click on that and go to View File, this is actually what the data looks like. So it's each of the entries, like this, digit, hand, finger lengths, the headers are there, and they're separated by a comma and nothing else. So everywhere there's a comma, it signifies the end of one cell and the beginning of another. Where there's a carriage return, that means it's a new row. So the first row of data is 1, comma, left, comma, 5.8, and then the second row, etc., all the way down to the end. So what R is going to do now is R is going to use a read function that's going to look at this file, and it's going to spot that it's got a header on the top, and it's going to use these to name the data columns like this, and then it's going to see that everywhere there's a comma, that's where it's got a new piece of data to bring in and import. So that's how it's going to work. We can look and see that back over here now. So we're going to read, we've got our finger lengths file here, our finger lengths CSV. I'm going to use this function read.csv. So read.csv is read a CSV file, and it's going to take the file name, and then I'm going to tell it that header is true. So we've got to tell it that there's a header associated. If we don't tell it that, it won't realize that the first thing is the first row is a row of names for each of the columns. And the only other thing I'm going to add is this strings as factor option. I'm going to set this strings as factor option to be false. So what will happen here is by default, let's go back and look at those data just there in R. By default, these are numbers, so that'll be read in as number 1, number 2, number 3. These are numbers, they'll be read in as numbers, 5.8, 7.5. These are words, so they're going to be read in unless we tell it otherwise, they're going to be read in not just as words, as strings, as a sort of series of letters. They're actually going to be converted automatically to a factor format, so a categorical factor. It'll be automatically converted into a category. Now, that's actually quite a sensible thing in this case, but sometimes you don't want that to happen, and I think it's better practice to read in your data with strings as factors set to false, so that it doesn't automatically try converting strings to factors. So I would set that to false, and then later on, I'll show you later on in a minute, that I would just do it manually for each thing, for each column of strings that I actually want to be factors, I would manually specify that just so I have a bit more control. It's not a huge deal, but it's just showing you this so you bear in mind that that is what it's doing. It's not, there's no surprises now. If we set this to strings as factors as false and do it manually, there'll be no surprises later on, whereas otherwise there might be. So we'll read that in. I'm going to read it in, and I'm going to store the contents of what's read into this object called my data here. So we can run that now as well. And we can print that to the screen, so it's not a big data file, so we can have a look at that. That's popped up over here now. So my data, it looks like it's read in well. So it's got a column called digit, and there's our 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, hand, left or right, and then the corresponding finger lengths here. In centimeters, I'm guessing, all the way down from 1 to 10. So we might ask, well, what structure is the data? So we can use that str command, structure. That tells us it's a data frame. So data frames are these really useful internal sort of representations of data in R. Data frame basically means that each of those columns is matched, so that each of the columns have to be the same length, so that the first entry is in this column is linked somehow to the first entry in this one and the first entry in this column, and so on all the way down. And what that means is with data frames, it's far easier to reorder them or pull out data and extract data, because it's all kept together, and they're all always kept, unless you really manually rejig things. These three observations will always be kept together in a single row, because they're part of the same observation. So that's what my data is. It's a data frame comprising 10 observations of 3 variables. We can see that there. And within it then, it's got objects digit, and digit is an integer. So those are integer numbers, 1, 2, 3, 4. They're whole numbers, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. It's got another object called hand. That's been read in as a character type. So again, that's a character string. It's not been converted to factor. And starts with left, 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 and then it gets bored telling us what's there, but there's dot, dot, dots, and that becomes right, right, right. And then finally, we've got one called finger lengths, and that's a numeric. So it's not an integer, it's a numeric, and it's numeric because it's got decimal points. So these are not whole numbers, these are decimal point data. There, so that's the structure of my data. So now we might want to start accessing, something we might want to do is start pulling out certain values from here and just either manipulating them or doing something with them or having a look at them. So if we go down here to our environment, we'll see that we've got something called my data. What we don't have though is something called digits. So if I list everything that's in the current environment with ls, the current environment, the only object in the current environment is my data. There is nothing here called digit. And this confuses people, because we'll type digit. Clearly I can see digit, and I can see hand, and I can see finger length. I can see them, they're there, they're inside my data. Why can't R see them, and why is it giving me an error? And the reason is that R works in these environments, and these are sort of this is a sort of a nested environment. These things here don't exist in the global environment, they only exist inside the my data environment. And so if we want to access those, directly, we'll need to not just type digit, but we'll need to type my data and then access it internally. So we can type, I actually started doing this over here and I've jumped a bit, but I'll come back up here to this. So here is we use the dollar notation. So we can type something like my data, $, and now the $sign says, well, we can look inside my data for the contents, and the contents are digit. So my data $, digit, now it returns that whole first column there, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 has been returned. And similarly, we can extract out the hand data, and we can extract out the finger length data as we want, like that. So that lets us pull out and extract the single columns or vectors of those data like that. So remember, they don't exist, they can't be seen unless you tell R to explicitly look inside the object my data for them. Now, I'm not going to show it, I haven't got it in the file, but it was in my older podcasts, and I got into this somewhat bad habit of using a function called attach. And attach is a function that essentially takes these values here and it copies them to the global environment so that you can then see them. And it might seem like a wonderful thing, but you can end up in a load of trouble with it, because you can end up with multiple copies of the same things. You can end up with 2 copies of something called digit and 2 or 3 or 4 copies of something called hand. And just when you think you're happy using the one you're meant to be using, lo and behold, it turns out you're actually using the one that was hidden from you and you couldn't see it. So one can learn the hard way, but what I'm going to do is just plead with you not to use attach unless you know what you're doing. If you know what you're doing, it's actually a perfectly fine thing to do, but generally speaking, and I've managed to train myself to not use it at all, even though I like to think I know what I'm doing, you're better off just not. So you're better off just using this $sign notation. And we'll see as we move on, there are various tricks that let us not worry about that. We don't actually have to use the $sign notation a lot, but we will have to use it a bit. So that's how you can access long vectors of those. The other way you can access this is just with a row column address, and that's what's being done here. So here we've got my data, and then these square brackets are used. So round brackets are used for functions. Square brackets are used to address elements within an object. So my data has rows and columns as well. So we can type things like my data, square brackets. If I type 1, 1, that's row 1, column 1, like that. And that returns for me the number there, which is in the first row in the first column. So it returns 1. If I ask for row 1, column 2, I expect this, and this is one of the tricks of programming, you've got to be able to sort of guess what you're going to get. So row 1, column 2, I expect that to be left, string left, and sure enough it returns the string. We know it's a character string, so it's between these inverted commas left. And similarly 1, 3 would be 5.8 over there, and so on and so forth. So you can start pulling, you can have row 3, column 2. What you can't have is row 3, column 4, because it's null, because it's outside it. It's not in column 4 doesn't exist, so it's returned null for that. You can extract out all of the rows, so you could kind of all the rows in column 3 like that. That's the third column of data, or you could have the second row and all the columns, which would be that. So it'd be digit 2, hand left, finger length 7.5, and this way you can pull them all out. There's another little trick. You can use the minus signs to extract to drop rows basically. So you can use it to extract out all the rows except. So there's my data C -1 -3. So that's going to drop row 1 and column 1 and column 3, and all it's going to do is return column 2 for me, which is the series of hand data, left, 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 right, 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 etc. Okay, so that's how we can access. That's data frames. That's how we can access the contents of data frames. I said to you that we might want to use left and right hand as factors, as categorical factors, not just as character strings. So you will find that even if you don't do this, many functions in R, when you pass on a character string like this, it'll kind of guess that you wanted a factor and it'll do it for you. But it's a good idea to manually specify them yourself for reasons we will see in a moment. So let's convert it to a factor. So I want to convert the hand column into a factor format, and we will do that by basically copying over the hand data with a factored version of it. So we're going to say my data $hand. So the column called hand in my data is going to get on top of it, it's going to become the factor. So we'll apply the function factor to that same column. So we'll take my data hand, apply the factor function to it, which will turn it into a factor, and then stick that back in on top of the my data hand column. So we're basically replacing the my data hand column with a factor version of itself. So let's run that. And now if we type structure on my data, str my data, we'll see that we now, instead of last time, we now get a data frame again with 10 observations and 3 variables, but now the hand column is not a strict character string, it's now a factor, and it's a factor with 2 levels. So the 2 levels are the unique observations. They are left, and so it's either left and right, and now it's internally represented that encoding as a series of numbers. So left hand is encoded as 1, right hand is encoded as 2. So everywhere R now sees 1, it will return left, and everywhere it sees 2, it will return right. And what's neat about this is generally, even though these are numeric representations, which is very useful for programming and modeling later on, every time we ask for hand, it'll actually show us the labels, not the numbers. So if we type my data $hand, it'll actually show us all the labels, left, 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 right, 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 and tell us what the 2 levels are. Now what's important is you'll see that the ordering of the levels is somewhat arbitrary. The ordering of the levels is decided. If you make a factor like that, unless you tell it otherwise, it will create the levels in alphabetical order. So it just so happens at the moment that left is on the left side and right is on the right side because L comes before R in the alphabet. But if you had a bigger, if you've got various treatments or something, sometimes they end up in the wrong order, and you might want to reorder those levels. So the way to do that is, and certainly that will affect things like plotting. So if you did want to do it, it's really quite easy. And again, this is a really good reason for why it's better to make your factors yourself rather than have R do it for you when you read in the data here with the strings as factors option. So the way to make factors yourself are down here. So this is a chunk of code that's not actually evaluated in the document when the markdown is knitted into HTML, so the eval is false. But here now I've basically done exactly the same. So I'm now going to make my data hand. I'm going to make it be a factor of my data hand with levels, and I'm going to specify the levels of right then left, not left then right. So this is the order in which the levels will be stored. So we'll do it that way. And now if I do structure of my data, I've now got a factor with two levels, but it's right and left instead of left and right. So this now would be change the order in which things were plotted or handled in the modeling. So that's the really easiest, honest way to change and refactor your levels. Specify them at the beginning yourself manually rather than have R do it automatically for you. Now, as I said, just for our sake, plotting the left hand on the left and the right hand on the right makes sense. So I'm going to put it back the way it was. Put it back the way it was. Will it go back? No, it hasn't gone back, so we'll have to do that manually. So we go factor levels equals C left and right. Structure my data, factor with two levels, left and right. Okay, everything's good again. I'm just going to type this to make sure it's correct. Yep, so these are the left hand data, these are the right hand data, just as before. Okay, so cool. So that's our hand data set. That's one way you can get data into R, is to read it in yourself using the CSV command. Now, the read.csv function is actually a shorthand for a sort of convenience shorthand function for a bigger, the more generic function is called read.table. And read.table here in the help file you'll see takes myriad optional arguments as inputs, so you can do things like change what the separator is, how to handle separators. So the separator is what demarcates each of the different cells and entries in the file. The read CSV function defaults to a comma. So everywhere it sees a comma, it's going to create a new cell. Now that's wonderful, unless you come from a country or are used to working in a place where you tend to use commas as decimal points. So here, for read.csv, the separator is the comma and this decimal point is the dot. So that's all wonderful for people like me. But there are many countries around the world that use the comma as a decimal point, and what they would use for a separator, I have no idea. But the problem there is if you use read.csv on a file where someone has got it encoded in, for example, the French region, so French encoding on their local computer, then when they save out that file, there's going to be commas potentially, not just between the cells, but there might also be commas between decimal points. So all these finger lengths would not be 5.8, they'd be 5,8, and R would get all manner of confused when it sees that it's got 3 column headings, but now it's got 4 entries here. So it's got 1, left, 5, and an 8, and it won't be able to match up the 4 entries here with the 3 headers. You'll get all manner of confused, and it will throw an error at you, and you won't know what's going on. So what you can do in that case is use this other function, read.csv2. You'll see that defaults to a separator that's the semicolon, so that's much clearer, a semicolon separator, and instead of the decimal point, it will use a decimal comma. You can do things like the read.dlim will use a hidden tab character as a separator and the decimal point is a dot, or if you find yourself working in the file that's really unusual, you can use the read.table and set all of those to whatever default you want yourself. You can use whatever decimal point, whatever separator you want, however it wants to skip. If there's a blank space, R will by default insert the NA, the not a number symbol. You can change all of that, so everything that you want can be changed there. You can tell it to skip the first 10 rows if you need to skip the first 10 rows because there's some weird output from some piece of equipment in your lab. You can do that. So read.csv works for me tons on a day-to-day basis, and I like this. Read CSV2 is going to help other people around the world who tend to So I'm going to say misuse the comma as a decimal point, and then the read.table function is your sort of generic go-to set it as you want function that you can change everything in. So you should be able to get your data in using some combination of these. So then, right, so that's how you get data in. So you can read data in from your own files, and that's normally what we would do. But another thing, great thing about R is for at least learning how to do stuff or playing around with functions, and in the examples you'll see this a lot. So in the help files, when they give you an example of a function, they'll tend to use one of the built-in data sets, and there are a truckload of data sets built in to R. So if we type data like that, we'll see a big list of all the different data sets, and a lot of these are quite famous data sets in statistics and data analysis, where we can test out and try out various types of models and plotting, etc. So loads and loads of them there, and one we're going to just use now quickly is the orange data set. So the orange data set is here. It is growth of orange trees, definitely, and if you can get some more help on that in a moment. So if we type data orange, you'll see what it's done is it's brought up, it's loaded that data set, and it's made it available here in the global environment. So down here in our environment, it's appeared here as orange. If we type ls now, we have my data and orange. We take a look at orange. It's quite a large, well, it's not that large, 35 observations. It's got orange trees, different trees labeled as 1, 1, 1, 2, 2, 2, 3, 33. It's got their age and it's got their circumference. So this is the growth of tree 1 at age 118. What was the circumference of its trunk? When it was 484, what was the circumference of its trunk, etc., etc., etc. I'm guessing these are days. I'm guessing that's days and age. This is about 4 years old here. So that lets us plot the different growths of those trees. So if you want more help on orange, you type help $orange, and it tells us exactly what it is. So it's the orange data frame with 35 rows and 3 columns, the records of growth of orange trees. And you'll see that down below in the example, it's got some examples that you can run. So you can just copy those and paste them in there, and you could see how to plot some sort of curved function on that. Okay, so I'm not going to go through what that's done there. That's definitely for later on in the course, absolutely, definitely. But you can play around. You'll see these data sets crop up all the time in the examples and help files. Right, so we'll go back. The other way, where else can you get data? The other place you might get data is you might want to read it directly off the internet. So here's an example of, we're going to use read.table to read a white space separated. So read.table defaults to using white space to separate the cells. So the reason I find using white space is dangerous, particularly, is if you have, so if we look here at my data again, if we had finger space length at the top, that would cause problems because that white space would be interpreted as a new cell. So we'd have 4 headers and only 3 bits of data. We'd have digit, hand, finger, and another column called length, but we'd only have 3 bits of data to go with those 4 headers. So white spaces cause problems with the column headers. That's why I would always put a dot or an underscore or no space at all between the names. But the other reason it can cause problems is if you've typically working with animal or plant data, you might have species names here, either common names or Latin binomial names, and those would typically have white spaces in them. And again, those are going to cause problems later on, which is why I like to use the comma separated files to be really clear about what's separating the cell entries. So that's what the read.table is going to do by default, and it's going to read from a website. So this is actually going to look up a website and it's going to pull down this Swiss squirrel data set like this. It'll take a little minute whilst it makes that connection. And now if we type head Swiss squirrels, we can get a feel for what's in those data. So those data are, again, a bunch of species names, the coordinates, XY coordinates they were found, and a various whole bunch of different data. I'm not sure what these are exactly, but these are all these different variables being read down. So actually that's gone wrong. That needs a header equals true thing. You'll see it's given the names of those as v1, v2, v3, v4. Those are variables 1, 2, 3, 4, 5, 6. But it's missed that, and that's because we don't have a header equals true there. So if we run that again, now if we type, I'm hoping this works. There, that's much better. So now the first column is called species, spec name, species name, squirrel, coordinates, etc., etc. So everything looks much better. So you can pull white data down off the web. So those would be probably the 3 most common ways you get information from the web, from local files first and foremost, in the examples from the built-in data sets if you're mucking around with stuff and trying to learn how functions work, or you might want to extract stuff directly from the internet somewhere. So going back now, what do we do with our data? We always want to do something with our data when we get it, so we might as well just do a quick plot. So let's return to our finger length data and just do a quick box plot. So this is where we're going to do, this is where we're going to take advantage of this little tilde notation here, this formula notation in R, so that we don't have to keep using the dollar signs to tell us where all the data are. So I'm going to do box plot here of finger.length tilde hand, and I read that as finger length by hand. So it's this thing is our thing we're interested in. That's our response variable. It's going to go on the y-axis. By hand is going to go on the x-axis. So hand is on the x-axis. It's got two values, left and right. We factor ordered that left first, then right. So I would expect the left hand to be plotted first, the right hand to be plotted second. And the trick here then is that formula notation then allows us to use this option, which is to specify the data. And the data frame we're going to use, the data we want to use, is in my data. So we've got data equals my data, and that then means we don't have to use the dollar sign long-handed notation here. We can just say finger.length by hand, and by the way, look inside my data when you want to go finding that data. Change the X label to hand, change the Y label to digital length in millimeters. That's surely not millimeters, that's surely centimeters. And then let's just run that. And this is what we get. So we get a really quick box plot. We're going to hit box plots soon in this module to see how we can pretty them up and make them better, and I'll talk you through them in much more detail. But this box plot gives us a quick indication here of how the hands might be, how the finger lengths on each of my left hand and my right hand how they are distributed. So we can see immediately it kind of looks like my left hand is slightly larger than my right hand, and we'll come back to that in a podcast very soon. We'll talk about what these are. These black lines are the median again. So this is the median, slightly higher in the left than it is in the right hand for whatever reason. I have no idea. So that's basically it. You can save data out in R if you want. So you can save data out to an R data file. I think I ran through this before. I don't like doing this though. I'm going to set eval equals false on that because I don't want that to run in the markdown. I almost never save data files out like this. Far better to have your script, far better to have the script reproduce the analysis. I would only do this if I had a script, and it does happen. Scripts that take ages to run, some mad model you're running takes overnight. You don't want to keep rerunning it every time. But for most purposes, this kind of simple analysis we're doing, I would never do this. Don't fill up your computer with .r data files unless you really, really want to and know what you're doing. Much better just have this file, run it every time. Every time you want to do it, rerun it again. And remember, if you've been working around and changing with your files, always at the end of it, restart your R session and run them all again so that you make sure that everything's clean and it will work with a brand new installation of R. Because otherwise, you'll come in the next day, you load up R, and the thing won't work. It worked yesterday at 4 o'clock when you were packing up to leave. It didn't work this morning. No idea why not, and the reason usually is there was something hanging around in the environment that you didn't realize was there, or there was some package loaded that was causing some problems or conflicts, and you only discover this when you actually shut down R itself and restarted it fresh. So your script should all run from beginning to end. So if we do something here, let's just do that. So let's restart R. So restarting the R session, says it over here. Environment's empty, we're all done. When we could rerun all those chunks again, or we could just knit this whole file. So I'm just going to hit that knit button and build a nice new file again. And that's us done. So we've got a nice file built again, hopefully all well. Finger lengths left and right, perfect. And everything's done there. So you've got a little assignment you can do. Ask you to do is to locate and find the built-in dataset plant growth and make a box plot, just as I've done here for the finger lengths. Makes a box plot for each of the treatment groups. So you've got to decide what is your response variable, what is the explanatory variable. So basically what goes on the y-axis, what goes on the x-axis. Have a think about that. Some answers are more correct than others, and come to some sort of conclusion about the difference. So make some sort of statement about how the difference between the groups or treatment groups. So ultimately you'll find the code for how to do that in the hidden from you now in this HTML file, but you'll find that in the raw markdown file for you to work through. You give it a go. And that's all. So we'll pick this up again. We'll start in the next block of podcasts hitting some more advanced plots, histograms and scatter plots and things.